the laws of indices. Before we start on the laws of indices, let's understand the terms we use when we are going to the introduction of laws. When I write 2 to the power of 3, obviously 2 is called the base and 3 is called the power. When I write a to the power of 2, a is my base. When I write a, there is a power. A is the base, and the power is an invisible one. So a to the power of 1 is a. It's not 0. So any letter, that's why when we write a times a, the answer is a squared, because we are adding these two together. That takes me to the first laws of indices. Law number 1. If you have a base to a certain power and you multiply, has to be the same base. You can't have a different base. It has to be the same base a to the same power or a different power. Here you write the base and you add up your powers. That's law number 1. So we have 5 to the power of 3 times 5 to the power of 4. So we 5 to the power of 3 at 4, 5 to the power of 7. Let's realize why we add the powers. Say we have this question. I wrote a small power so I can explain. 2 to the power of 2 means 2 times 2. Then we have times, and 2 to the power of 3 is 2 times 2 times 2. So I've got 1, 2, 3, 4, 5. So it'll be 2 to the power of 5. But I could have written this here by writing the base and adding the powers. So first laws of indices can be found out without knowing the rule, but the problem is if it was 2 to the power of 2,000 to the power of 3,000, it would take you half a day to list 2,000, 3,000 twos and then count and add them. So here, law number 1, one more example, 6 to the power of 3 times 6 to the power of, say, minus 2. So you write the base, you add up 3 and minus 2. Of course, we explained in the directed numbers that when two signs follow, is a multiplication rule. Positive times negative is negative. So we have 6 to the power of 3 minus 2, which is 6 to the power of 1, and we don't write power of 1. So if you have, say, 5 to the power of 2, times 5 to the power of 4, times 5 to the power of 10. Since the bases are all the same, we write the base and we add up the powers. 2 at 4 at 10. That is 16. Let's go to law number 2. This is when you divide. Say you got a to the power of m divided by a to the power of n. Well, as an advice, I always tell my students, do not use that symbol of divide as long as you can help it. Change that to a fraction line. Because we've got 3 symbols: divide, divide, and divide using bus-stop method. This is the one I want to use. So it would be a to the power of m divided by a to the power of n. Again, the bases are the same. So you write the base and you take away the top power minus bottom power. But if it's in this shape, it would be first power minus the second power. So m minus n, m minus n. So that's law number 2. So we have 2 to the power of 6 divided by 2 to the power of 4. That's 2 to the power of 6 divided by 2 to the power of 4. Let's explain what happens, and then we apply the law. So I need to multiply 6 2's at the top, because it's 2 to the power of 6. And here 4 of them here. So 2 and 2 cancels, 2 and 2 cancels, 2 and 2 cancels, 2 and 2 cancels. So we have 1 times 1 times 1 times 1, which is 1, 2 times 2 over 1. And 2 times 2 is 2 squared. But I could have got that answer by 6 take away 4 at the beginning. So applying the laws of indices. Number 2, you write the base, top, I don't mean top, the first power minus the second power. That's 2 squared, which is of course 4. It was written in the form of 2 to the power of 6 over 2 to the power of 4. You write the base, top power minus the bottom power. So that would be 2 squared, which is 4. Let's go to law number 3. Here I've got the base, which has a power, and I want to reach more power. So my base 2 has reached power of 2 and then reached further power of 3. So that means this bracket is times by itself 3 times. Inside, we have 2 to the power of 2. So that's 2 times 2. That is 2 times 2. And that 2 times 2. So what do we have? 1, 2, 3, 4, 5, 6 2's multiplied by each other. So 2 to the power of 6. But could I have got this answer straight from here? Yes, multiply the powers. So 2 to the power of 2 to the power of 3. When your base has multiple powers, multiply the powers. When your base has multiple powers, multiply the powers. So you've got, say, 2 to the power of 3, to the power of 4, to the power of 5. So you write the base, and you times 3, times 4, times 5. That's 60. So as a formula, we have a to the power of m. A is the base, m is any power, reaches another power. A has multiple powers. You write the base, and you multiply the powers. That is the law number 3. More examples. Say my base is 5. It reaches minus 1. Then it reaches minus 4. So you write the base and you multiply the powers. So with 5 to the power of minus times minus plus 1 times 4 is 4. And 5 to the power of 4 is 5 times 5 times 5 times 5 is 625 if you work it out. Now, let me take you to law number 4. We have a base to a negative power. Your power is negative, and you want to have a positive power. Well, in order to change your power from negative to positive or positive to negative, it costs you 1 over. 1 over the same, but with a positive power. Example, you have 2 to the power of minus 4. So you write this as 1 over 2 to the power of plus 4. I won't write the plus because it's invisible. And 2 to the power of 4 is 2 times 2 times 2 times 2. Let me write it down. 2 times 2 times 2 times 2, which is 1 over 16. Now, law number 4 also can be used as a fraction. Say you got a fraction a over b to the power of minus m. But I'll give you the answer in a minute. But let's go through the ritual and see how effective the answer is. Based on what I've taught you, in order to change the negative sign to positive sign, it costs you 1 over a over b to the power of plus m, which is 1 over a to the power of m divided by b to the power of m. Both of them will get a power. Now we're doing division of 1 by a fraction, or a fraction by a fraction. So that's 1 divided by a to the power of m over b to the power of m. And if you remember, we keep, we change, we flip. And one lots of b to the power of m over a to the power of m stays at b to the power of m, a to the power of m. Now put it back again as inside a fraction. So the result is this. You don't need to go through that. So another law number 4, when you're dealing with fractions, is when you got a over b to the power of minus m. All you have to know, the minus of the power turns the fraction upside down. That becomes b over a to the power of plus m. So this is also law number 4. Law number 4 here, we are just non-fractional base with the power of minus becomes 1 over power of plus. With the fractional one, your minus becomes plus, but you turn this upside down, which acts as 1 over a over b. So let me give you more examples on law number 4. So 4 to the power of minus 2. To calculate, 1 over 4 to the power of 2. 1 over 4 squared means 4 times 4, 16. What about 2/3 to the power of minus 3? So what I do straight away, my minus 3 becomes plus 3 at the expense of turning 2/3 upside down. So we have 3 cubed, 2 cubed. That 3 times 3 times 3, 27. 2 times 2 times 2, 8. So we have a 1/5 to the power of minus 2. But it's a fraction. Your minus power becomes plus power, and 1 over 5 becomes 5 over 1. So it's 5 to the power of 2 is 25. Let's go to law number 5 now. Law number 5 is when your base has a fractional power. Do not mix this with law number 2. Let me show you law number 2. That was law number 1. And law number 2 was written here. Because we got fraction here, don't be confused with the fraction here. We have two bases we are dividing. Here we have one base and the fractional power. Now, the only thing we can do with this is to write it in a different shape. The meaning is the same. A to the power of m over n is the same as a under a root form. M, the top number of the fraction, becomes the power of a, and the denominator of the fraction drops in here. So a to the power of m over n, all these are reversible actually. You can go from this end to that end. A to the power of m. Make sure the root is long enough to take the whole thing, even if it's a fraction. And then n goes well inside the root, not outside, not too far, exactly inside. For example, 8 to the power of 2/3. It can be written as 8, which is the base, goes inside. 2, the numerator becomes the power, and denominator drops here. So we know how to write it. How do we calculate? Two ways of doing it. Either you square 8 and find the cube root, or cube root and then you square the answer. The second one is better, because when you square, you sometimes, if the number is too big or you cube the number, then you find it very difficult to find the root without a calculator. What I do, I find the cube root of 8 first. Cube root of 8 is 2, because 2 times 2 times 2 makes 8. So cube root of 8 is 2, and I make my answer reach the missing power here. So that's 4. Let's have a look. So you got 32 to the power of 2/5. That would be 32 to the power of 2/5 root. Okay, let's do it the bad way, not the wrong way. Say you try to work out what is 32 to the power of 2. That should be 1024. Then you're trying to find the 5th root of 1024. It's going to be extremely difficult. Without the calculator, what number times itself, times itself, times itself, times itself, going to give you 1024. Without calculator would be very difficult. So what I'm going to do, so to make it easier to calculate this without the calculator, 32 to the power of 2/5, we wrote it as 32, 2 here, 5 here. Find the 5th root. We know the 5th root of 32 must be 2, because 2 times 2 times 2 times 2 times 2 times 2 is 32. So the 5th root of 32 is 2. And then you make these 2 reach that power. The answer is 4. The 5th root of 1024 is 4. So this was law number 5. And let's have more examples of this one or this one. I don't know, here without arrows. That's what you got to remember. So how about writing 16 to the power of half? But here you got to be careful, especially when you go backwards. So what should I be writing? 16, the base here. 1, the power goes here, and the denominator goes into here. But do we write powers of 1? No. So when we write 16, already 16 to the power 1. And by convention, we do not write power of 2 either. So what I'm saying, 16 to the power of half, it's just written as root of 16. Both the power of 1 and square root of 2 is now become invisible. So a to the power of half is just root of a. What about a number to the power of 1/3? Well, 1 would be written here, and 3 goes there. But by convention, we do not write powers of a, powers of 1. But 3 got to be shown here. So when we go backwards, say we have root of 24, and I want to write it as a fraction form. I must remember that there was an invisible 1 of 24 and square root of 2 here, which was not written, and it was made invisible. So I can write this as 24 to the power of 1/2. Let me show you again. You see, we can go backwards. A to the power of m rooted n can be the base. M goes up there and n down here. I did exactly here. 24 had the invisible power of 1, invisible root of 2. To write it as a fraction, it can be invisible. You write the base, that becomes the numerator, and this number in the root becomes your denominator. Let's have more examples. Combining law number 4 and 5, for example. Say I have got 64 to the power of minus a sixth. And I'm asked to work this without a calculator. So I've got mixed up both laws of indices number 4 and laws of indices fractional number 5. So first I'm going to use law number 4 to write it as a positive power. 64 to the power of 1/6. So I've got a fraction, on the top is 1, and here is law number 5, which is written as 64 inside the root, 1 the numerator as a power, and 6 goes in here. 1. The 6th root of 64 is 2. To the power of 1, just 2. We didn't have to write this power of 1. So the answer is half. Let's have 27 to the power of minus 4/3. So here, because of the minus, I use law number 4. So I've got 1 over law number 5. Law number 5, you write the base, which is 27. 4 becomes the power, and 3 becomes the root. And if you remember, I said do not calculate 27 to the power of 4 and trying to find the root of it, cube root of it. Find the cube root of 27. It's much, much easier. The cube root of 27 is 3. Because 3 times 3 times 3 makes 27. And now make your base reach power of 4. So it's 1, 3 to the power of 4 is 3 times 3 times 3 times 3, which is 81. Now let's give you a 9 over 16. So both to the power of minus half. Law number 4. You got a fraction. So your fraction turns upside down as at the expense of minus becoming a plus sign. So that becomes 16 over 9. A quarter minus half becomes plus half. And we know what plus half means. It's a root. It's a square root. Make sure your root is long enough because you need to be covering the whole fraction 16 over 9. Of course, powers of 1 go here, powers of 2 go, square root of 2 goes here. So 1, the numerator becomes the power, and denominator shows the number of roots. As you remember, we said we don't write powers of 1, and we don't write square root of 2. And then I'm taking square root. Square root of 16 is 4. Square root of 9 is 3. So the answer is 4/3 or 1 1/3. Okay, we have now finished all 5 laws of indices. Just to summarize, I write the formulae for the 5 laws of indices in order. So now, law number 1, a to the power of m times a to the power of n. When you multiply, you add up the powers. Law number 2, when you take away, when you divide, your divide might be in this form or in a fraction form. You write the base, first power minus the second power, or top power minus the bottom power. Law number 3, when you got a to the power of m reaching another power. Remember, when you have multiple powers, multiply the powers. Law number 4, when we got a negative power, it's a single number. To change minus to plus or plus to minus, because you 1 over. Of course, if you had a positive power and you wanted negative power, that can be written a to the power of minus m. So to change the sign of the power costs you 1 over. Law number 5, a to the power of fractional power would be written as base goes here, m here, and n goes in here. These are the 5 rules. The only thing you got to also know that any number to the power of 0 is 1. The proof is advanced. So example, 100 to the power of 0 is 1. 5 to the power of 0 is 1. So any number to the power of 0 is 1. This concludes our lesson on laws of indices. You need to memorize these laws, and by practicing, you remember them better and better as you go along, and you can see its application with practice after practice. These laws of indices, you have them in year 7, year 8, year 9, year 10, year 11, first year of A-level, second year of A-level. You never escape from these laws of indices in maths. So best to learn them as quickly as you can. I hope you enjoyed this long lesson, but I've completed the whole laws of indices. So it should be easy for you to follow. See you next lesson. Bye for now.